So now guys, find the equation. The example is very long, so I'm really sorry for making it into pieces or parts. Either way, like we need to find the cycle of efficiency, which depends on the compression ratio. So this R equals the compression ratio, right? And how do we find the compression ratio? It's there in the first video, but to recap, it's gonna be V1 minus divided by V2 equals to P2 divided by P1, okay, to the power of 1 divided by gamma, right? So it's gonna be 17 P2 equals to 17, okay, and P1 equals to 1 already because it's 1 bar. So it's gonna be 17 divided by 1 over 1.4. It's gonna equal to 7.56. So that's actually the compression ratio. If you do have from the start V1 divided by V2, because let's go back. If we said that we don't have actually V1 and V2, so we can't apply it to the compression ratio, but we don't have V1 and V2. Maybe you can have V1, but you don't have V2, so you can't do that like mathematically, or you can do that, but you will end up finding V2. So that's another problem, right? So we need to have 2 units already. So P2 divided by P1 to the power of 1 divided by gamma equals to 7.56. So it's also with no units. You need to be careful. It has no units. The bar cancels this bar, okay? So that's the compression ratio. So to find the cycle efficiency, it's gonna be 1 minus 1, 7.56. Okay, 7.56 minus 1. It's gonna end up with, if you do the math, it's gonna end up with 55.48 efficiency. It does make sense, okay? That's for the Otto cycle if you go to the theory part. And yes, I'm gonna explain the Otto cycle theoretically, or the essence. And I'm gonna make 2 videos in Arabic and in English too, okay? So now let's find the work done. So we do need to find the work done to find the mean effective pressure. Mean effective pressure is the PM, okay? So PM equals to work done divided by stroke volume. So we do know what stroke volume is. In the first video, it is the VP equals to, it's the VP which equals to V1 minus V2, right? And what's the stroke volume? As we said, the stroke volume is like, it goes like this. Let me just draw. So this is V2 and this is V1, right? The space in this place is the stroke volume. It's the difference between V1 and V2. And why do we consider V2 here and V1? Because it's the constant. So that's the constant part here. That's where the work done in V2 to V3, there's 0 work done, right? Because you're just stopping. You're not doing anything. Like imagine physically you're not doing anything physical. So your work done is 0, right? But when going to 1 to 2, there's work done actually. It's isentropic compression. And 3 to 4, there is isentropic compression, expansion. Okay? So that's the thing about that. So, and there's the Qn in the constant. So to have a heat addition, we need constant. And that's the Q out. Okay? So you need to understand this stuff, guys, to make it easier for you. So the stroke volume, we already have the stroke volume. Put it to solve it. Okay? So you can check the first video. It's 0.7546. Okay? And the work done equals to cycle efficiency, which is 0.5548. If you take the percentage, multiply the heat supplied, which is 374.30. That's the heat supplied. So that's the heat supplied. Okay. So we multiply with the heat supply, 374.30. So finally the work done equals to 207.66 kilojoules per kg, because for the percentage we have no units, so there's no units, so you just multiply it with the kilojoules per kg we find. So it's like multiply by 1, it's going to be kilojoules per kg. Okay, so that's the answer. So we need to find now the mean effective pressure, which is the PM, which is 207.66 divided by the stroke volume, 0.7546, which equals to 2.75 bars. So the stroke volume, a lot of people don't really get it. What's the stroke volume? So I might show you guys how do we get the stroke volume, but it's gonna take a lot of time. And I do really explain in the previous video, the part one video. So please check it out. So, but the stroke volume is, let's consider that V1 equals to 2 and V2 equals to 3. So this is the PV, right? That's 1, that's 2, that's 3, and that's 4. So this is V2 and this is V1, and this is the VP. That's the stroke volume. So it's gonna be VP equals to V1 minus V2. So it's gonna be negative, but for the sake of the argument, so it's gonna be 2 minus 3. Okay, or just let's say it's 6. So it's gonna be 6 minus 3. So the stroke volume equals to 3. So that's how it works. It's pretty easy. Okay. So that's it, guys. Thank you for really watching this video, and I'm gonna make another example for the thermodynamics in Otto cycle, and also we can move on to the diesel cycle pretty soon. Yeah.